Hello everyone, welcome back to MrMiers Math channel. In our rational functions chapter, we're going to talk about the last section, section 9.6, which is solving rational equations. Alright, so let's get into it. A rational equation is an equation that contains rational expressions. Duh. When each side of the equation is a single rational expression, you could just cross multiply to solve. So we've done this many times before. At introductory levels of math. If we had 2/3, equals x over 12, we could just cross multiply. We'd get 24 equals 3x, and then solve from there. So in this case, divide, and we get x equals 8. And that lets us know that 2/3 is the same thing as 8/12. All right, pretty simple. So we're going to use that and apply that to some rational equations. So one similar to the one that we just did is x over 3 equals 12 over 18. So we're going to cross multiply. So that means 18 times x, and then 3 times 12, which is 36. Divide by 18, and we get x equals 2. Remember, the reason why we can cross multiply and solve is simply if we wanted to get rid of if we wanted to get rid of the denominators here, we'd multiply by 3 on both sides. That would cancel out that denominator, and then we'd multiply by 18 on both sides. And that would cancel out that denominator, and that would leave us with 18x equals 36, which is what we just had. Awesome. So in example 2, of course, we're always going to step up the difficulty. We're going to cross multiply, so 4 times x is 4x, and then 3 times x plus 1, that's 3 times that whole quantity, so then we would have to distribute, subtract 3x to solve for x. So we get x equals 3. All right, and to check our solution, we just plug it back in. All right, so plug 3 back in where you see x. You'd have 3 plus 1, which is 4. And obviously 4/4 equals 3/3. They're both 1. All right, so let's say it's not just simply a rational expression on both sides. Now, in one side, we have 2 rational expressions. Okay, in this case, what we'd want to do is we would want to find the LCD, the lowest common denominator of each one of the denominators in the fraction, and then just multiply each term by that LCD. And here's the reason why. If we do that, if we multiply 2x, in this case is the LCD, if we multiply 2x times each one of these fractions, the x's would cancel out, the 2's would cancel out, the x's would cancel out, and we have left an equation with no denominators, no fractions, so it's easier to solve. So that's just a really simple way that we can solve one of these rational equations. Just multiply each term by the LCD, and that's it. All right. So in example 3 here, first we want to find the LCD, and I'm just going to write that off to the side. We have x, and then we have 3. So the LCD in this case would be 3x. So now we're just going to multiply 3x times each one of these. And what I like to do is just write it by each one of these fractions. All right, so it's not like we're multiplying 3x 3 different times. We're just multiplying it by the whole function here. And the reason I'm writing it 3 times is so that we can cancel stuff out right on the paper. So these 3's will cancel out, and we'll just get 2x. The x's will cancel out, and we'll just get plus 3. And these x's will cancel out, and we get 3 times 3, which is 9. All right, so it's a little bit easier to just do your work, and you have to do less in your head and more just right on the paper, which is nice. So subtract 3, divide by 2, and we get x equals 3. Of course, it says check our solution, so let's go ahead and do that. So I'm going to rewrite the equation, but plug 3 in everywhere I see x. And now this equation says 2/3 plus 1/3 equals 3/3. Well, that's true, so this does work. All right, moving on to example 4. Once again, let's find the LCD. All right, we have 2 3x's. Okay, and then we have a 2, so the LCD would be 6x. All right, that's the lowest common multiple, and we're making it, we're trying to get rid of the denominator here, so we're going to multiply each one of these by that LCD. And then we can just cancel things out as we go, so x cancels out that x, those are common factors there. 6 over 3, we have common factors of 3, which would leave a 2. 6 over 2, common factors of 2, which would leave a 3. And then the x's would cancel out, and then 6 over 3, once again, common factors of 3, which would just leave 2. So now we have 2 times 1, which is 2, 3x times 1, which is 3x, and then 2 times 4, which is 8. Now we can solve this simpler equation. Subtract 2, divide by 3, and we get x equals 2. And of course, once again, we're going to check our solution. And as we do that, I'm just going to do some of the computations as we go along. So plugging into where I see x, we'd have 1/6 plus 1/2 equals 4/6. Well, that doesn't have the same denominator as those two, so let's change it. 1/2 is 3/6, and 1/6 plus 3/6 equals 4/6. So it works, so that means it's a solution. It makes the original equation true. All right, moving along here. Now notice this first term in this equation doesn't have a denominator. That makes the LCD pretty easy because these two are the same, so that means the LCD is just x minus 1. So when it's more than one term in the factor, I put it in parentheses. That way we remember that what it takes to cancel out an x minus 1 is another x minus 1. Now when we're rewriting it, I'm going to multiply this right away, so we get 8x minus 8 plus 2 equals 2x. Let's combine like terms here. 8x minus 6 equals 2x. Get our constants on one side, variables on the other, so I'm going to subtract 8x. Get negative 6x, divide by negative 6, we get x equals 1. Now the problem here is when we plug that back in, when we plug 1 back in here, it makes the denominator 0. So since it makes that denominator 0, which is undefined, that solution actually doesn't work. All right, moving on. In example 6, let's find that LCD. On the right side here, we don't have any denominator. Well, we do have a denominator. It's implied that it's 1. So that makes our LCD finding a little bit easier. We have x and x minus 1. Remember, x is a factor. X minus 1 in itself is a factor. Okay, so the LCD is x times x minus 1. Now, yeah, it gets a little messy, but we're going to write it on each one of these and see what cancels out. Right here, x minus 1 cancels out, then an x, and of course nothing cancels out there. So now let's rewrite it. So 2 times x is 2x. 3 times x minus 1 would be 3x minus 3. All right, and then we have 2x times x minus 1. All right, so on the left side, we're going to simplify. So we have 2x plus 3x, which is 5x. On the right side, we're going to simplify this. We get 2x squared minus 2x. Now notice that this is a quadratic. All right, so if we want to solve this quadratic, we should get everything on one side and see if this thing is factorable. So we're going to subtract 5x. That would give us negative 7x, and then we're going to add 3 and see if this thing is factorable. Luckily it is. We get 2x minus 1 and x minus 3. So if we set each factor equal to 0 and solve, we'll get 1/2 and 3. And then once again, what we should do is check each one of these solutions. So on in blue, I'm going to check 1/2. So we have 2 over 1/2 minus, minus 1, which is negative 0.5. Okay, and then 3 over 0.5 equals 2. Now 2 over negative 1/2 would be negative 4. 3 over 1/2 would be 6. And negative 4 plus 6 is 2. So that does work. And then let me do this in black with 3. So if we plug 3 in, we'll get 3 minus 1, which is 2. 3 over 3. 2 halves plus 3 halves equals 2. Yep, that's right, because that's just 1 plus 1. Awesome. Last example here. Okay, in this one, it's helpful to know what this factors to be, if it's factorable at all. And it is factorable. It factors to be x plus 1 times x plus 1, or in other words, x plus 1 squared. All right, so what we're going to do is multiply by the LCD, which is x plus 1 squared. Okay, and now we're going to cancel out those common factors. So this is the same thing as that, so that's going to cancel out. All right, and then right here we have an x plus 1, which is going to cancel out one of the x plus 1s in the numerator there. And then on the right side, I'm not going to write this as x plus 1 squared when we simplify. I'm going to write it in its original form here, because we're going to have to solve that equation. So we get 3 plus 2x plus 2 equals x squared plus 2x plus 1, which is its standard form, its original form that it was in this problem. And now we're going to solve this equation. All right, so we could combine like terms on the left side. So we get 2x plus 5 equals x squared plus 2x plus 1. And now get everything over to one side. This is a quadratic that we want to check out if it's factorable. So we're going to subtract 2x, and we're going to subtract 5. So if we subtract 2x, that cancels that out. Subtract 5, that makes it negative 4. And this is a special case, special pattern, which factors to be x plus 2 times x minus 2. So when we set each equal to 0 and solve, we get x equals negative 2, and then x equals positive 2. Now, of course, we'd want to check our solution. I know this might be tiresome, but it's necessary to see if both of these are actually solutions in this equation. So if we plug in, let's say, negative 2, and I'll use this red for negative 2. If we plug negative 2 in here, that would give us, let's see, negative 2 squared would be 4. 4 plus negative 4 would cancel out, so that's just 3 over 1. And then in the second fraction, 2 over negative 1. We're checking out, does that equal 1? Well, that's 3 minus 2, and that does equal 1, so that does work. And then in orange, I'm going to do positive 2. So if we plug positive 2 in, 2 squared is 4, plus 2 times 2, which is 4, plus 1, that's 4 plus 4 plus 1, or 9. And if we plug 2 in right there, we'd get 2/3. Well, 3/9 is just 1/3. So we have 1/3 plus 2/3 equals 1, which is true. Awesome, folks. So that was the last section. If you liked that, enjoyed it, found it helpful, please like, subscribe, and share. Thank you, and have a good day.